Here we have our berm. And we've had some really nice red clover on it. It's going to seed. So we got that, but we've got lots of other woody plants that have been growing up. And in a typical kind of permaculture system, you do chop and drop, like it's really exciting. You have all this plant growth, and then at a certain time of year you chop it, you let it drop down, and then that carbon, you know, recycles back into the soil and starts building the soil. Here in our climate, we get more woody plants. A lot of times the chop and drop, like you see it in a tropical climate, and those plants grow so fast that they're not woody. Like you can tap it with a machete and you can cut through it. This stuff is super woody, and our chop and drop system right now is like a weed eater with a blade on it. So it's not quite as fun, but what we want to do is create more cover crops. We want to seed more cover crops, and we want to smother some of the weeds out. And the weed is just a plant grown where you don't want it, but you know, our eventual goal here is to stabilize this slope with perennial trees.
Well, mix perennial trees and all kinds of like.
Yep.
Herbs,
herbaceous, and
plants.
Yep.
Shrubs, fruit shrubs, all kinds of a complete mix. Yeah.
Yep. So the main water actually comes through here, flows down through here and into that pipe, and from that pipe it goes into the diversion box. So let's go check out the filter over here. And you see how steep the back cut is here? Like this is because the slope, we have a lot of slope here. And so you have to cut deeper to get enough berm to keep the water from flowing over this way. So the steeper the slope, it's just like a terrace. You know, you can't make it too wide because then your drop is very steep. So here it's the same thing. And this is like the steepest you would want to see a back cut right here. This is pretty stable soil. It's not very fertile. It's a saprolite. Saprolite is just a rock in its last stages. It's kind of a generic term for rock that's basically almost sand or dust. And we have a lot of that here. Up top we have more clay, but this has been cut before and filled it out for the greenhouse, and the previous owners cut this bank back. So we're kind of working with what we had, and we're going to be improving the soil. This you can't see it, but all this is red clover going to seed, so I'm pretty happy about that. There's a few babies popping up here. One thing I didn't cover in the class is being sensitive to old structures, being sensitive to existing trees and different parts of history on the land. This had a little pond in it at the top, and it had some old rock work in it already, but it was a lot narrower and it was covered over with wisteria. You could see the wisteria vines on the walnuts over there. This whole thing was a tangled jungle. And basically what we've done here is similar to the bottom wetlands. We've lined it with clay and we've created these dams. So you see the rock dams here, but underground also there's clay dams. But you can't see it because we have gravel, we have biochar, gravel, and some topsoil on it. So the water comes down the main system and it comes out the pipe under the rockwork there. And we tried to, the old steps were there, and we tried to just kind of work with what was there and keep it and incorporate it and kind of, you know, make the usefulness out of it again. The water comes down, same thing as it does bottom. It fills up underground before it starts to overflow. It comes into this one, it comes into this one. If we get a lot of rain, you can see the after effects. This whole thing will fill up, and these dams actually slow the water down. And then it could just perk through here, and it's all about slowing the water down and filtering it as it goes. And it heads to this pipe. It goes horizontal and goes down the hill. These are all wetland plants, and we've got some grasses kind of taking off here.
So this goes into the diversion box as well.
Yep, this is part of the main system that goes down to that pipe, yep.
That goes to the swale we just walked through.
Yep. Any questions about this area? This is like, to me, this is one of the most exciting areas because this is a renovation of a gully. This gully wasn't eroding, but the water, I didn't explain this, sorry. The water was, this dam wasn't here. So this being a key feature on the land, the water was heading down through here naturally with the rain, and it's basically like a funnel, and it would work its way down, and there was no dam there, so it would go off the bank and over behind the biochar. So we've horizontalled that. We've stopped that flow, and we're shooting it horizontal. And then you take the energy out of the water, so it slows it down.
Do you have any control over how much water comes through this?
The only control I have is by tuning the spillway, the height of the spillway.
So what happens if you get a major rain event and the water goes, away from the dams? It overwhelms the dams.
It can go over or through them is fine. Yeah, there's an emergency spillway that way, and then it also comes this way. So yeah, you always want to think about like worst case scenario, how can the water get out? Definitely.
You said you lined it with clay. Is that clay you brought in, or you just got?
No, we had it here. Yep. And it was kind of a mix. The bottom is a little sandy, so it's kind of cool. It's like I'd say like a 50% coefficient infiltration rate, or maybe, I don't know exactly, but when it rains, we're holding most of it, but after about 2 or 3 days, what's left in the bottom just kind of soaks in, and then
John, we officially have 2 minutes. We'll obviously go longer, but we should probably try and...
Okay, yeah, let's hoof up the hill and just see our water catchment here. So this is our main swell right here, and it keeps going. We've got a crazy amount of catchment here. I think we have about 1/3 of a mile that this keeps going. All the way back, if you look through the tree line, all the way back basically to the pine trees over there. So we get a lot of water. It comes through here. This is our overflow right here. It works its way down into this little sedimentation pond. That sedimentation pond was already there. It was that little frog pond, and we lined it with rubber. Again, we're respecting the history of the site, and we're improving its usefulness. And that's basically, you always want to do that, because you can't replace something like that, you know? And you can't replace the trees and things that take time, like hundreds of years, you know? So you want to, not that the trees did, but just the whole landscape. Things take time to establish, and they have value. And when you can work with it and recognize that, you can really increase the value of it. Here we have a little point of discharge here. And I'm not sure I think there's water in the line, so we'll see if there's water. And this will be gravity water, if it is, from the pond up top that was pumped with the windmill. So let's see if there's any in here. Yeah, that's at the top of the hill.
You get a certain amount of overflow this way, but wouldn't you also get some water going that way? Because that's not very high.
That's high. Well, there's a pipe there that it actually heads into this other little catchment.
But so you think that the bulk of the water from the swale will go this way and it won't go that way?
It sure will, yep. It's worked, it's overflowed a few times. So this works awesome because here you can do anything you want. We can add in drip lines, we can add in different, we've got several of these points on the farm that we can do things with. I'm trying to encourage the system of flood irrigation luckily we don't have drought this summer, but for fruit trees planted here on the berm, if it gets real dry next year, and by spring, I imagine the top pond's gonna be full, the bottom pond's full, we can just flood this whole thing. We can flood it right here, and we can water the fruit trees. The fruit trees love to go in, get deeper, and it just keeps everything moist. Any questions?
What is this fitting on the end? It's like a...
That's just a hose fitting, so we could tie on. That's a quick disconnect that you can just plug in a hose, and that hooks onto here, a 2-inch. Yep.
What's the slope in the swale?
Okay, you can do different slopes. You can 1 in 300 fall this way. I've got it mostly level this way, but what I actually did, I think is the first, is I put a first flush system on this. So most of it is completely flat. Towards the far end where we get a lot of rain and a lot of potential nutrient discharge, because the animals are uphill in this little valley, it's actually sloping downhill, only slightly that way. And what it does, first flush, it goes to the end. If we had time, I'd take you guys over there. It's already collecting all kinds of nutrients. You can see it, the straw collects over there, everything. And it fills up until it starts to back flood this way. You guys could just imagine there's another pond on top, and that's the important thing. Like there's a pond that we gravity feed, and that's what did this. So this is pretty impressive. I don't know the pressure right here, not a whole lot of pressure, but you're thinking more volume, low pressure, high volume, instead of high volume, or instead of low volume, high pressure. So it's another way, a different way of looking at things. And the larger pipe, the 2-inch pipe going all the way up the hill, cuts down on water friction. Anytime you're pumping water through a pipe, there's a certain amount of friction. So the smaller the pipe, the more the friction, the harder it is to pump. So the bigger the pipe, less friction. But then at some point you can't, it's, you know, anything above 2 inches just gets really expensive, really expensive. So we'll just call it, and if you guys got any questions, we could keep chatting about it, and then maybe we could come over after if anybody wants to.
Size of the upper pond relative to the lower pond?
The size, I think it's about twice as big, maybe. Yeah.
Big up here?
The pond up top is like 20 foot deep, so it's super deep.